Hello everyone. Just confirm for me if you can hear me well and if everything is fine, and also like we wait few minutes until everyone joins and then we can start. All right then. So if everything is fine, we just wait a few minutes to wait like for others to join, and then we will start today's session. All right, so let's get started. So, in today's session, we will continue on the entity side, and now we will see in details how to create the relationships between the entities and what is the impact of choosing or like putting the annotations, especially when it comes to many-to-many and so on and so forth. And also I will teach you how you can detect or how you can know how to place the entities. So we'll start from this place right here. So like first we will start adding the relationships between category and game. So we said here that a category has many games and one game belongs to one category. So like based on this on what we just said, So first I will start with the category or even the game. So like both of them are fine. So like I will have both of them at the same time. So here, what we said exactly. So we said a game belongs to one category. So like based on what we discussed in the beginning, we said that a game belongs to only one category. So if it was different, so like we need also to update our ERD diagram. So how to do that? So first I will create a field of type category, and I will call it category. So like I will import it from the correct package, which is this one. And then from the category side, what we said that within one category, we have multiple games. So like within one category, so like let's say, for example, action or arcade or something like that, we might have, or like we might find many games. So for that, we will create a list of games. All right. So like we will have a list of game and we will call it games, or like game list or games. So let's import the list. And now we have our attributes. So now how we can read, or like how we can determine the relationships. So from the game side, so what we said, so like we said, within one category, we can have many games. So this means that we have many games to one category. All right. And from the category side, we have one category to many games. So like we can find many games that belong to the same category. Now let's see what are the attributes that we have in here. So here for the many-to-one, there is nothing really to add, but when we go back to the category, here we have an attribute called mapped by. So this is how Hibernate will be able to do the mapping, or to map the list of games from the game entity. And here this mapped by, so this is very important. So the mapped by, it should be exactly this attribute or this field name. So I will just copy it to avoid typos, and I will paste it in here. So now if I navigate, it will navigate me to the category field. All right, so now we are done from this side. Now from the game, so first of all, I will just start the application and let's see the impact of adding these two annotations. So now everything seems to be fine. Let's first check the logs. So here, first of all, what we did. So it created all the tables, and here we have the game. And then, okay, so maybe let me jump in here and I will show you directly the impact. So here, what do we have? We have the game field, or like the game table, sorry. What do we have here? So automatically it created a new field or a new column called category ID, and how this was created, or like how the name was created. So first, since from the game we have a many-to-one relationship. So the many-to-one relationship is with this category field. And then we go to the category table, and of course, since here we have a base entity, it will go and take this ID as the ID. So like it will give it the table or the field name underscore the name, or like the ID, or like the name of the ID field of my entity. So for example, I will change this one to identifier, and then just let me make sure that we have the create option. Okay, create drop. Fine. So now if I restart my application, so it will drop the schema and create a new one. So now if I refresh my database and I go to the game table, so here look how it is named right now. So now it is named category and then underscore identifier. So if I continue on doing that, so here, for example, let's rename this one to only cat instead of category. And of course, in the category, we need to rename this one cat. But for now, I will not rename it. Just I want to show you that if we do not have the same attribute, this might throw an exception. So I will just restart the application and let's see what will happen. So here we see that we have an exception, error creating entity with name entity manager, and so on and so forth. If we scroll down and try to go to the caused by part. So here we have a collection. In category games, which is mapped by a property name category which does not exist in the target entity. So that's why I told you it's really important that the mapped by should be, or like should have the same name as the attribute that we have in here. So here it says that in the game entity we don't have any attribute with the name category. So this is the first information that you need to keep in mind. This is very important when it comes to adding the relationships. So now, just to continue for our example, I will just rename this to cat, just to be like to have the same attribute name as in here. Now I will restart my application and everything should be fine, and we will be able to see the impact in the database. So now if I refresh, if I go to the game column, and here you see that now it's called cat underscore identifier. So I hope this part was clear. So what I will do right now, so in case, for example, I don't want my my join column name not to be, I don't want it to be this this field name concatenated with the ID of my entity. So for that we have another annotation. It is called join column, and here we can give it a name. So for example, for now, let's give it ID cat, just an example. And let's restart our application. So is it fine for you that the attribute name will be cat underscore the ID of the entity? That should be fine. So like this annotation is optional, but if you want to give it like a specific name, like a name that you want to precise, just go ahead and use this join column annotation. All right, so now if we check the impact in here under game, we will see here now we have ID cat as a column name, and of course the ID now is called identifier. So I will just go ahead to base entity and rename this back to ID, since like it's shorter and simpler. This is the only reason. And here I will just bring it back to category as well as in here. All right, so now maybe we can call this one category underscore ID. Or like, as I mentioned, we can just remove it and it will always get the category, and then it will concatenate it with the ID. So why should we use this join column annotation, since it's already optional? So here the impact, or like the good thing, is that we can precise, or like we can give the name in the beginning. So if in the future I want to change this attribute in my Java code, so this will not impact my database. So this is very important, because when it comes to production, we will not have this create drop or this update. So it will be always validate in here. All right, so it will not be create drop or something like that, because in production we should not give the possibility or the ability to hibernate, or like to our backend system to control the database or to do any changes. So this is very important when we want, or like if we want only to update the Java code and not to impact our database fields names. All right, so now we are done with the category and with the game. So as I mentioned, let's resume this, how we can read that, or like how we can put the relationships. So we mentioned in here that one game belongs to one category, and one category has many games, or like has a list of games. So since we said category has a list of games, I just need to go ahead and create a list of games, and then I create it in here. And then in the category, since our game belongs to only to one category, so all I need to do is to create a field of type category. And then when it comes to the annotations, what we said, so like we said that many games belong to one category. So this is where the many to one comes from. It's many, like the first word, many, entity name or class name, to one, the relationship. All right, so like it's many to one. And from the other side, it's the opposite, which is like one category to many games. All right, so I hope this was clear, or this part was clear for you. Then let's move on to the comments. So now we mentioned that a game has a list of comments, and one comment belongs to one game. So let's go ahead and open our game entity and also our comment entity. And now I think it should be straightforward. So we will have our private, no, not this one, but a list of games. we will have a game, only one game in here. So we will have a game for the comment, since since a comment belongs only to one game. And for a game, we will have a private list of comments, and let's call them comments. So in the same way, so here we mentioned that we can have one comment to many games. All right, and here we have many in here we have many comments to one game. So because for one game we can add many comments, so here we have many to one. So we have many comments to one game, and of course here we need our join colon, and the name, let's give it, or like comment ID, for example. All right, so now from the game, it will be the opposite. So like one to many, and then we need our mapped by attribute, which is game, as we mentioned in here. So if we change the name, we need, of course, to change it right here. All right, so I hope this part was also clear. Now we can move to the user and the wish list. So like we have a wish list and a user, they have a one-to-one relationship. So this is also important. So like we started with an exercise, or like with explaining the category and the game, which is one-to-many and many-to-one. And then we applied what we learned into game and comment. So like this becomes so clear. And now let's move on to the one-to-one and see how one-to-one relationship can be done. What are the options? What can we do with that? All right, so now let's move on to user and wish list. I will close these two classes, and then I will open my wish list entity and my user entity. All right, so since here for the wish list, let's add, let's give it the entity annotation. And also we can extend our base entity. Right, so here for the wish list, we don't have any attributes, or like we can have attributes, but for example, let's say maybe private string the name. So like maybe let's say that the user can give a name, or like can customize the wish list name. So I will just copy these annotations right here just to move faster. And now, since we have a one-to-one relationship, so one-to-one relationship, all I need to do is to create a user entity, or like a field of type user. And in here, in the user, all I need to do is to have a field of type wish list. Let's call it wish list. So now, when it comes to one-to-one, so all I need to do is to have a one-to-one relationship. All right, and also let's add one-to-one from here. So for now, let's add one-to-one annotation from both sides. Now let's rerun the code, or like let's rerun our application, and let's see the impacts of this change. So now we make sure that the application is up and running and everything is fine. So we do not have any exceptions while creating the database. So let's refresh right now. Now when we go to the user entity, so we have here a wish list ID. So we have a new attribute, or a new field in our user table called wish list ID. Now if we go to the wish list and see the columns, we have the ID, and we have the name, and we have also a user ID. Also, if I do this, so within IntelliJ, the ultimate version, if you have this database tool, you can select all the tables, and then you can show the diagram. So now when showing the diagram, maybe I will try to zoom in a little bit. We focus only on these two entities. So here you see that we have two relationships. So this one-to-one relationship, so maybe I'm gonna zoom in a little bit more so we can focus on these two entities. So here we have a wish list and we have the user. So our relationship between wish list and user is called bi-directional relationship, because from the wish list we can go to the user, and from the user we can go to the wish list. All right, so now we can also implement, or like we can also put in place a one side, or like a one directional, or like a unidirectional relationship. So here, how to decide when it comes to this one. So like the decision is quite easy. It's not a theory, it's not something final, but it's something that might help you decide when or like which entity should be the owner of the relationship. So here we ask one question. When, for example, now the user wants to add or to create a wish list. So when creating a wish list, who should exist in the beginning, or like who should exist first? The user or the wish list? Can I create a wish list without a user, or can I create a user without a wish list? So this question will help you a lot determine and decide which one to exist first. If you cannot answer this question, it's also fine to keep the bidirectional relationship between the two tables. All right, and here all you need to do, maybe just keep it as like make it lazy loaded. So in this case, for example, you can avoid the infinite loop fetching. So like fetching the wish list, fetch the user, and the user will fetch the wish list, and so on and so forth. So like you will be in an infinite loop around here. So now, among the attributes that we have within the one-to-one annotation, let's check it in here. We have target entity, cascade, fetch, and so on and so forth. And we have a mapped by, which is optional. So this means like this field that owns the relationship. So this is what I just mentioned. When you add the mapped by to one of the one-to-one annotations, this means that you are deciding who owns the relationship. So for example, if I do one-to-one, and here I say mapped by, let's say, wish list in here, just to make sure if I did not make a typo. So here I'll just copy paste it. And now I have my wish list. So now if I restart my application, we can close this one and also this one. And then I will refresh my database and I will try to display again the diagram. All right, so here we have our user and we have our wish list. So let me zoom in. So here you already see that we have a one directional relationship, and this direction, it goes from the user to the wish list. And here we added the mapped by to the wish list. All right, so in this case, what does it mean? So it means that before creating a wish list, we need a user. All right, and also inside the wishlist table, we no longer have the user ID. So here, so like what we did right now is the expected one, or like the relationship or the type of the relationship that we want to put in place is that before creating a wish list, I need to have a user. But in case, for example, or like for another use case, I would like to have the user first and then the wish list first and then the user. So all I need to do is to come in here and add the mapped by on the user side. So as we saw in here, so this mapped by means the field that owns the relationship. This element is only specified on the inverse non-owning side of the association. All right, so like it's the inverse. So like when we have this element, it's the inverse. So this means I need my user before creating the wish list. All right, so wish list already owns the relationship, but the user should exist before creating. Sorry, it's the other way around. The wish list should exist before creating the user because we have the wish list ID in here. We have the foreign key, which is the wish list ID in the user. So we need to have the wish list before creating the user. Or okay, so like this is theoretically, but when it comes to the code, we can create the wish list, get the ID, and then create the user. All right, or the other way around. So like when it comes to the code, it's like we have so many ways to overcome this, but this is just to explain what this means. So now let's add a mapped by user in here, and let's remove it from here. Again, if I restart my application, and then I need to refresh my database, and maybe I will only select user and wish list. So this is my user and this is my wish list. So now, as you can see, the direction, or like the arrow direction has changed. So we have inside the wish list, we have the user ID. So now what this means, so we have our user. So like, since in our application, or in the context of our application, we know that the user will be automatically created when a user registers on KickLock. So like, we will get the user, we will save it in our database, and then we can go ahead and create a wish list, like by default or default wish list for our user. All right, so this is how it is gonna be. So like, inside the wish list, with the wish list, we need to have the user. Like, the user should already exist, because if we try to insert a wish list with a user that does not exist inside the user table, so like, we will have an issue. But here also, let's check something. So here, if I do edit, sorry, not edit data, but edit the modify table. So now when we check the user ID, so the user ID, as you can see, it's nullable. All right, so like, it can be null. So this means I can create a wish list with an ID user equals to null. So like, a wish list that will not be associated, or like, it does not belong to any user, which should not be the case for our application, or like for the application generally speaking. So every wish list should belong to a given user. All right, so I hope this part is clear. Now we can move on to the next part. Also, let's try something before moving on. So if I move this annotation, if I remove, sorry, not move. So if I remove this annotation, we will see here that we have entity attribute is not marked with association annotation. Also, I can completely remove this from here, but this doesn't make sense, of course, because we need to keep the relationship. All right. So now let's move to the next part. So like, the upper part is now done, like category, game, comment, wish list, and the user. So now we still have another relationship, which is wish list and game. So for the user and notification, and the user and game requests, so this should be straightforward, because like, we have a one-to-many and many-to-one relationship, which we already covered in here. So we will just do it faster. But now we have a relationship, like a many-to-many relationship between wishlist and game. So this is really, really important and interesting. So let's open our game and wishlist. All right. So what did we say in here? So like, when we prepared the ERD, or like the entity relationship diagram, we said that a wishlist can have many games, and one game can belong to many wish lists. So like, from this, we have this many-to-many relationship. So when we have many, like when we say that something, or like some entity has many relationships, it's always a list or a collection. So here I will have a list of games, and let's call it games. And from the game side, we will have also a private list of wish list. So wish list. So let's call it wish lists. So here, since we said it's many-to-many relationship, so I will just add many-to-many. Many-to-many relationship. And also from here, I will add a many-to-many relationship. So this one should be many-to-many. All right, so now I will not add any other annotation. I will not do anything else. I will just restart my application and see the impact. So now what do we have? We have 7 tables, right? So user, category, and so on and so forth. Now, if I refresh my database, we have now 9 tables. So this is very important. So can you find out, or like, can you figure out what are the new 2 tables that were added? So it is this and this. So it is wish list, or like game wish lists and wish list games. So from this one, we see, or like, what we can understand from here. We understand that Hibernate was not able to determine the direction of the relationship. So what it did, it just created two tables just in case. So like Hibernate will manage everything when it comes to persisting the data. But from here, we created one table which goes from game to wish list. So like a game has many wish lists, or the other way around, which is wish list has many games. All right, so like this is the many-to-many relationship. And here we know that many-to-many will introduce another entity, or like an association entity between these two entities. And this is what Hibernate already created for us. Game wish list and wish list games, or like game wish lists and wish list games. So like from game to this and from this to this, or like game wish list and wish list games. So now let's see how we can add, or like what we can add when it comes to this type of annotation or like relationships. All right, so first I will just try to add some annotations. All right, so like I will just try to add some annotations. So here we have a mapped by. So let's say wish lists. I hope it's written in the correct way. So nope, another typo. All right, so now again, this mapped by, so this field, the field that owns the relationship required unless the relationship is unidirectional. All right, so our relationship is not unidirectional, so we have a bidirectional annotation, or like relationship. So it goes from game to wishlist and from wishlist to game. All right, so now if I just restart my application, so now I set, or like I decided that the wishlist is the owner of the relationship. So now if I restart again and then I refresh my database, so now if I refresh the tables, so now I have 8 tables instead of 9 tables. So what was the entity that we kept in here? So here we kept the game wish lists. So like from game, we have many wish lists. And in here, of course, like for the columns, it's like super easy and super straightforward. So like we will have games ID and wish lists ID. All right. So now we said, or like how did we decide? So like the wish list owns the game. So this means what? Like, does this mean that when we create a game, or like if we want to create a wish list or like many wish lists, should we associate or like have the game already created, or the other way around? So like who owns the relationship? Again, worth mentioning. So this might not be very important, or like how to say that, critical, because we can control everything over like or using the code. All right, but here having a good relationship, even like for the namings and so on and so forth, this is very, very important to know. All right, because then when it comes to the code, we set the list of games for the wish list, and we set the list of wish list for the game, and this will be automatically managed and handled by Hibernate. So like there is nothing really that we need to do, or like nothing, there is not too much, exactly. So this is the correct word. So like there is not too much that we need to do. All right, so now how, like, of course, for example, I want to change the name of this relation or like this association entity or association table. So for that, as we have a join colon, we have another annotation. It's called join table. All right, so for the join table, we can give it a name. So the name, let's say game wish list, for example, or wish list. So like it's perfectly fine. I just want to remove the S from here so we can find that, or like we can get it easily. And then what do we have? We have here our join columns. So here we need to define the list of join columns. So the join columns should be a list. All right, and as you can see in here, the join column is a list of join column annotation. And if I click on this one, you see it's an annotation. All right, so let's move on and create or like add the join columns. So the first one, it will be a join column, and for the join column we can give it few information. So we have the name in here. So the name, the first one, it should be the game ID, since now we are in the game entity. So here I will call it game ID. And then we have inverse join colons. So here why we have a list of join colons, because for one entity, for example, I want to have a join colons, or like if I have a composed or like an embedded ID, so an ID composed of many fields. So here I can specify so many of them, like many join colons. So here I maybe just put it in one line, so like it's much more readable. And in here, this inverse join colons, it's also a list of join colons. So here I will add a new join colon and I will give it a name. So here this will be a wishlist underscore ID. And now for this one, all right. So now for this update, or like this change that I made, I will just restart my application and see the impact of this. So like everything is fine, the application is up and running. I don't have any exceptions within the data, like within the startup of the application. So now if I refresh my tables, so here you see that the game, like the join table is now called game wish list instead of game wish lists. All right, so now it's taken into consideration this name, or like this join table name. There is something very important in here we can see together. So when it comes to the columns, so we see here that we have our game ID, all right, and we have here our wish list ID. So the game ID is a varchar, and also we can check the foreign keys. So the foreign keys will give us more information. So we see here that the game ID, this field right here, is, or like has the relationship, or like belongs to the game table, and from the game table it belongs to the ID of the game table. And the wish list ID belongs to wish list and the ID of the wish list. So why I'm mentioning this? So let's assume, because this is something that I saw on a code that someone asked me to review it, and like he has some issues while inserting the data and like working with the data with the many-to-many relationship, and the reason it was this one. So here he has something like this, and game ID. So now if I restart, so when you see it the first time, it seems, or like it looks correct. All right, so the application starts, everything is fine. But here, if I refresh and if I go to game wish list and I have a look on here, so I have game ID pointing to wish list table and the wish list ID pointing to the game ID, which is not correct. All right, so like which is not correct, because here this one is meant for the game, and this one is meant for the wish list ID. So put in mind, when you have the join table annotation, the first one, the join columns belongs to the entity where you add the join table annotation, and the inverse join columns belongs to the other entity, like from the other side. All right, so this is very important to remember, and this is really important, so you do not forget this part. All right, so now we are done with the many-to-many relationship. So like I hope everything was clear. Now we can move on to finish the implementation of the notification and the game request. So like I would like to keep this as an exercise, but we will do it also now. So we have with the user and a notification. So let's go to notification and also user. So here we said that a user has many notifications, and one notification belongs to one user. So here the user has a private list of notification, and let's call it notifications, and the notification belongs to a user. So here we have a private user and then user. All right, so So here it will be one to many, one user to many too many notifications, sorry. And here many notifications to one user. And here we need to add the join colon, and let's call it, for example, user underscore ID. And in here it will be mapped by user. So since here we have our user entity. So now if I restart my application and go check if my relationships were correctly created. So here if I go to the user, we have one key, we have colons, and then in the notification we will have a foreign key, which is the user ID. All right, so like when we create a notification, we need to have the user or the user ID. So here we have our user ID as a foreign key inside the notification table. So in the same way, we will continue, or like we will finish our game request. So let's go to game request. And as we mentioned in here, so a user also has a list of game requests. So I'll just duplicate this one. And here it will be a game request. And this one, let's call it game requests. And for the game request, I can also copy this one just to move a bit faster. So here we have a user and a user ID. So if I refresh or like restart my application, so first we make sure that everything is up and running and the application is running correctly. Now I will refresh my database, and here when it comes to game request, for example, I have a foreign key, which is the user ID. All right, and here I have these 4 columns, like the title, the status, the ID, and I have my user ID. So now what I will do, I will select all the tables and try to show the diagram to make sure, or like to see if everything is correctly implemented. So here we have user, we have a wish list. All right, so here I think we missed one table. So game wish list is not showing. Okay, so we have a user with notification, game request, and the user has a wish list. But there is a weird annotation, or like a weird relationship between the comments. So here, let me check the comment. Maybe we made a mistake. I don't think this, okay, so just to be sure, I will just rename this one or this field to comment, to text, or the content. Maybe content would be better. But because I have this relationship, this weird relationship between the comment and the comment itself. Okay, because I have this comment ID. Okay, let's check where this comment ID is coming from. Comment ID pointing to game ID. All right. Okay. So this should be game ID. So this was the issue. So this should be the game ID. Let me restart the application. So like you see, it's really important that you check everything before moving on. So now I will try to display the diagram again, and then I will come and try to answer your questions. I don't see my diagram anymore. So diagrams and show diagram. Okay, let's refresh diagram and then show diagram. I'm not sure why it's not displaying anything. Okay, maybe it's a bug. Let's refresh again, and also I will try to see if everything was correctly created. Again, I will check the comments. So okay, game ID pointing to game ID, or like to the game entity. And in here we have the category, but why the diagram is not showing? Okay, so now I think it's better. All right, so now we have our, maybe I will try to display it in this way. I hope it works. Nope, it does not. Anyways, so I will display it as a pop-up, and we will try to make it fit the screen. So we have our game and category in here. We have also a game, it has a comments, and also what do we have? We have a wish list, and between the user and the game. So like the user has a wish list, so like I will just move it from this side. So it's a one-to-one relationship. And in here we have a game wish list. So here I think something is missing. So here something is missing because we have the relationship between, nothing is missing. So here is the relationship. I just didn't see it. All right. So our diagram looks exactly the same as we implemented it, or like as we designed it in the beginning. So this means that everything is fine. This means that our implementation is correct. So sorry, I will try again and see if I display the diagram directly. So maybe here, I don't know why it's not working. I really don't know why. But anyways, we just saw in this pop-up diagram that we have all the entities with the correct relationships. All right. So now there is something also important that I would like to show it to you. So we have a many-to-many relationship between the wish list and the game. And in the future, like when we implement the application, we want to remove a game from a wish list, or like do the other way around. So like mainly it will be removing one game from a wish list. So for that, we will prepare few methods. All right. So we will prepare some methods. So here I will open my my game. And in here, I will add few methods. All right. So here I will add a method called add wishlist. So I will make it a public void add wishlist. And then I will ask for a wishlist as a parameter. And here it should be wishlist and a wishlist. All right, so now if I want to add a wish list, so here all I need to do is my wish lists dot add the current wish list, and then from the wish list that I have as a parameter, so here I will make it this dot just to avoid the confusion, and then wish list dot games or get games dot add this. Or like, okay, so like the auto completion from IntelliJ. So here, when we want to add a game, so because when we have a many-to-many relationship, so maybe let me explain it in here. All right. So here I have my wish lists. So I will call this one WL, and here I have my games, or like my game. And between these two entities, I have a many-to-many relationship. All right. So this means that we will have our wish list, or like game wish lists table. So here I will just call it game underscore wish list table. So now how Hibernate will manage this when we want to add a new game to a wish list. So we need, so here let's say that we have the wish list with the ID 1, and here we have a few games with the ID 1, 2, 3, and 4. So this is a 2. So like 1, 2, 3, 4, and 5. So when we add one game to the, when we add many games to the wish list, so like it will be like this. So like for this, or like this part is the game ID, and here the wish list ID. So we have the game ID 1, wishlist ID 1, game ID 2, wishlist ID 1, game ID 3, wishlist ID 1, and so forth. All right. So how Hibernate will manage this? So for example, I want to remove one line from here. I want, for example, to remove this game from the wish list. So like it's a game that I don't like anymore. So I would like to move it, to remove it or delete it from my wish list. So technically, when we talk about Hibernate, all right, so like when we talk about Hibernate, we don't have this entity at all. So this entity, we don't have it within our code. So as you can see here, we don't have any entity called game wishlist. So we cannot directly interact with this one. So we need to interact with this relationship. All right. So when I want to remove this one, I need to break. So I need to break the relationship from here as well as from here, and this will result in breaking or removing the relationship from here. So since a game has a list of wish lists and the wish list has a list of games, so when it comes to adding or removing something, I need to do the following. So here, since we are inside the game and I want to add a wish list to the game, so here I do this dot wish list dot add wish list, like the new one that I want to add. And then I need to get the games of that belongs, or like the games that belong to this wish list, and add the current game. So this will result in this one. So here, for example, I want to add the game number 5 to the wish list number 1. So adding to here, so like adding to the game the wish list with the ID 1. So here this will be linked to the ID 1. So this one. And then the wish list, I would like to link it to the ID number 5 of the game. So Hibernate later on will come to this table and he will insert an ID 5 for the game and wishlist ID 1. All right. And for the removing also, it will be the same. So let's see how the remove. So remove wishlist. Okay, really this new feature, or like this new auto completion of IntelliJ is really incredible. So like I don't know how it read my mind that I want to remove a wishlist, or like maybe it was based on this one, and here it just gave me the code that I need. Anyways, so this .wishlist.remove. So I would like to remove the wishlist, and then I need to remove this also from the game's relationship. So it will result in removing it from here. All right. So always keep in mind when you have a relationship. So we are not done yet. There is something else we need to do. So when you have a relationship, always when you have this, like the place or the entity that has this relationship, you can add these add and remove methods to handle this one. But this is not enough to make everything work out of the box, because within the many-to-many relationship, we have few properties. All right, so we have few properties. Among them, we have this cascade. So cascading type, so like the operations that must be cascaded to the target of the association. All right. So this means what? This means when I want, for example, so here, let's say, for example, I want to remove the wish list. Or before moving to the wish list, let's try another example, which will make more sense. So here I have my category table and I have the list of games. All right, I have also my game table, and here we have a one-to-many relationship. All right, so now I have my category ID 1 and game 1, 2, 3, and 4. So this is a 2. So 1, 2, 3, and 4. Now what should happen? So this is the question. What should happen if I remove the category number 1? So automatically, so like when we think about it, automatically I need to remove all the games that belong to that category. Otherwise, they will be orphaned. Orphaned, this means that we'll have an ID category equals null. And this might be acceptable if you want to, if it fits into your business requirements or like the business requirements of the application. But most of the times it does not make sense to keep orphan data. All right. So for this case, when I delete a category, I need to delete all the games that are linked to that category. So here I need to use a cascading strategy. Cascade. So I need to use a cascading strategy. So when I do something, what I want to do to all the things that are related to this one. All right. So like here we mainly talk about the relationship between category and game. So when we remove this, for example, I want to remove all the games. Now let's go back to our example in here. So when I want to add a wish list or remove a wish list, what I want to do, I want to have a cascading thing, or like a cascading strategy. So here within the ManyToMany, as we saw, we have this attribute or this property called cascade. And for the cascading, we have all, like all the operations: persist, merging, removing, refreshing, and detach. So detach will detach the entity. If I refresh something, it will refresh everything. If I remove, or if I merge, or if I persist. All right. So let's go back in here. So now I will choose my cascading types, or like what I want to do as a cascade. So here, cascading type, I would like to persist, and I would like to merge. So I don't need the refresh. So I want to persist and merge. So merging means when I add a list and remove a wish list, so this will be automatically merged in here. So like it will be merged in this entity right here. All right. So this is what we mean with merging and persisting. So when I persist something, so when I add something in here, I want it to be persisted. And when I remove something in here, I want the result also to be merged and persisted, of course. All right. So like persist is creating, and merging is when I do an update. So this is important. Also, there is something important. Here, beside the cascading, we have something called fetch. By default, it's fetch type lazy. Fetch, what does fetch means? So, whether the association should be lazily loaded or must be eagerly fetched. So the eager strategy is a requirement on the persistence provider runtime at the associated entity must be eagerly fetched. And the lazy strategy is a hint to the persistence provider runtime. So this means what? This long text means what? So this means when I fetch a game entity, or like a game from the database, what should I do with all the relationships? So all the relationships, for now we are talking about this one. All right, because when it comes to the comments, also we have a fetching strategy also. So like for all the relationships, we have always a fetching strategy. So the question here, when I load a game or a list of games, let's talk only about one row in the database. So when I load a game, do I need to load all the wish lists, or like the wish list that this game belongs to? So maybe for example, if you want to display something like this, so maybe let's say we have a Spider-Man game, so like Spider-Man game, and let's say for example this belongs to 100 wish list. All right, so in this case that would be easy to say that I want to load the wish lists eagerly. So I will have them when I request the game, so I can just return wishlist.size to calculate the size of this one. But here you need to be careful about this, because when you have the fetch type eager, so behind it will perform the query that will fetch the data from these two entities. Like, so the query, it will be something like this. So the query, it will be select. So let me make this bigger so you can see it. So it will be select star, for example, from game. Let's call it, okay, so let's call it G, for example, G.star. So this is the native query, all right? So from game G, inner join our game wishlist. So game underscore wishlist. Let's call it game wishlist on game wishlist.id.game ID equals my game.id. So this is the first part. And then we need, of course, the other side. So here we have also inner join wishlist. Let's call it w on wishlist.id equals my game wishlist underscore id. All right, so like this is the query that will be executed in the background. All right, so like you need to be careful when it comes, because like having the so here, because having this fetch type eager is not for free. All right, so like it's not really for free. So if you only need it for basic things, you need to think about it. If you need it for I don't know, like other things, or like if you want to have more information and so on and so forth, so like you might think about, or like you might consider having it in here. So here, this cascading type, it might be important in here. This fetch type, it might be important when it comes to the wish list. All right, because when I want to fetch a wish list, I would like to fetch all the games that are inside this wish list. So here I can add a cascading type, or like a fetch type eager, sorry. So here I can make it eager when it comes to the wish list, because I would like to see, or like I would like to have all the games when I fetch only one wish list. All right. Okay. So now we have our methods. We have almost everything. So we have all the relationships already implemented, and everything is fine. So now I guess let me optimize the imports, and also let's commit these changes. All right, and this one I can commit. Okay, adding entities relationships. All right, let's commit and push. Okay. All right, so it's not something that is really recommended, but I always do it. I always just ignore the checks. So now we have all the changes available right now. All right. So now I will move on and try to answer some of your questions. If you have questions about what we just saw in here, go ahead and ask them. So I see already some questions. All right, so here I see one question. So game wishlist table can have a primary key too. So this is true if we create a separate entity for the game wishlist, but in this case, I just wanted to show you the many-to-many relationship. So you do not need to create yourself the association entity. So it will be 100% created. Okay, so in the beginning it will be created, and then we will create it using the SQL code. So like we'll create the whole database using an SQL code. So it will be under the hood, or like ready in the database. But for Hibernate, we will not have, or like in the Java code, we will not have an entity called game wishlist. So for that, we don't need an ID, because the ID will be an embedded one. So like an embedded means that the ID is the combination of the game and the wish list. So for example, we will not have a line or an information in our game wish list entity with, for example, ID wish list ID 1 and game ID 1. This we will not have it twice in the table. All right. So even if we want to insert it twice, we will be blocked, because this will break the constraint. All right. Right. So if yes, how to add a primary key column? So for that, you need to switch. So you need to switch. This means what? This means that you no longer use the many-to-many relationship from Hibernate, but you need to create your own entity. You call it game wishlist, and then you change the relationships to be many-to-one and one-to-many within this new entity from the wishlist and from the game side. All right, so like the wishlist will have a relationship with the game wishlist, and the game will have another relationship with the game wishlist, which is gonna be many-to-one and one-to-many. All right, so here you forgot the relationship between the user and comment. So this is true, and I would say we do not need this relationship because we will have our auditing part within the application. So within the auditing, we will know the comment belongs to which user, like who is the user who created that comment. So this will remove this relationship. And even in the later on, we can also like use joining between the comment and the user to know, like to fetch the user information. So this is not really needed, but also we can add it. So this makes sense. All right, next question. How can we implement this relationship between category and itself? A category can have subcategories, one-to-many. A category can belong to a parent. Okay, really good question. So I can show you this. So it's not part of our application, but I can show you this. All right, so let me go to the code, and I will have another example. So like I will create a new entity just as a test, and then I will show you how it can be done. All right. So for this use case, so now we will see a use case where an entity can have a relationship with itself. So here I will have an entity that has a relationship with itself. So let's say it's gonna be a one-to-many, for example. And the best example for this one is if I want to have a menu. All right, if I want to store my menu in the database. So for the menu, we can have levels and sublevels. So this means we can have, for example, this level right here, or like we can, instead of menu, we can have like the folder structure or something like that. So for the menu, we can have many elements. Like this might be, for example, the and elements. We can also have an element here and another one in here. This one has a subcategory or something like that. So like this is the idea behind. So here, for example, we can have things like this. So this means what? This means that a menu or like an element has a parent, and the parent is itself is a menu also. So let's say, for example, we have here menu 1, menu 2, or like let's call it maybe sub menu 1, and here sub menu 1 element 1, for example, sub menu 1 element 2, and so on and so forth. And here it will be sub menu 2, and here sub menu 2 sub menu 1, for example, and so on and so forth. So this means that the menu entity has a relationship with itself. All right, so it has a relationship with itself. So like the parent of a given record in the or a given row in the table or in the database has a relationship with the menu, or like has the parent, which is a menu also. So I will create an entity. I will call it menu, and then I will create my entity menu. So I will just paste my annotations. Okay, maybe this should be fine. And here I will say entity, and I will extend also my base entity just to get rid of the IDs. All right. So now, how to think about it? So here, what do we have? We have a menu. A menu has a relationship with a menu itself, and the menu has a parent ID. So let's represent this in a table, for example. So our table, it will be like this. All right. So our table, it will be, or like it will have an ID, and it will have, for example, text or label. Maybe label is better. So like we will have a label in here, and here we will have a parent ID, or like ID parent or parent ID, it's also the same. So in this case, how it is gonna be? So we will have, for example, here, let's try to represent this one. So we will have a menu 1. So menu 1 does not have a parent, so the parent will be null. All right, so in the second row, we will have a submenu 1. So it will have an ID since it's going to be incremental, and it will be a submenu 1. So submenu 1 has the ID, which is the parent ID 1. So here the parent should be 1. All right, so this is the parent ID. Then if I move on, I will have this submenu 1 element 1. Let's give it an ID 3, submenu 1 element 1. So who is the parent of this one? So this is the parent, right? So this is the parent of submenu 1 element 1, which has an ID 2. So here we will need to give it the parent ID equals 2, and so forth. I hope this is clear, or like this representation is clear. So how to achieve that when it comes to the code? So when it comes to the code, so I will have my private string label. We said it's going to be label for the text, and then we will have a private menu, an object of type menu. All right, so let's call it parent, for example, and here we will have a private. So here comes the relationship. So like the relationship, we said like a menu has many submenus, and submenu belongs to a menu, right? So here, let's consider this one is a submenu. So the submenu has a parent. So now when we speak, or like when we try to talk about the menu, so the menu has a list of submenus, right? So here it will have a list of menu. Let's call it submenus. All right, so let's import this one. So we have a list of submenus. So here, the only difference, or like what might be confusing in this part is, for example, is like, okay, so here in the side, in the menu, I have a menu and the list of menu. Imagine that you want to create a menu entity, and you will create another entity, you call it submenu. So in the menu, you will have a list of submenus, and in the submenu entity, you will have a field of type menu. But now we want to have everything within the same table. So like we can have an infinite hierarchy. So that's why we need to keep everything in the same table, or in the same entity. So now when it comes to the parent, so it will be a many-to-one relationship. So like, because a menu, so like the parent can be the parent of many menus. All right, so let's give it a join colon with the name. Let's call it parent ID, parent underscore ID. And now when it comes to the list, so like it's going to be also a one-to-many relationship, and here it will be mapped by mapped by parent. So mapped by parent. So like it should be this field name. All right. So now all I need to do is to restart my application, and we will see, okay, so something is wrong. So we have getters and setters. What is wrong in here? Okay. Cannot find symbol get games. Maybe it was not processed. So for now, just for now, I will remove this code just to be able to move on, and then we will come and solve it later on. All right, so now we have our application up and running, and if I refresh my database, we will have our menu. So first, let's check the menu relationship. So we will have an ID, we have a label, and we have a parent ID. All right, and then we have a foreign key, which is the parent ID, and it references the menu table with the ID. So like it references this one. So if I try to show it in a diagram in this way, so you see now that my menu has a relationship with itself. Sorry, I'm not able to drag this one, or like to display it a bit better. I don't know why. Let's try again with the other option, show diagram. Okay, I guess now it works. So here we have our menu, and the menu has a relationship with itself. So we have the label, the parent ID, and the ID. And then when we want to insert some data, it will be exactly the same. All right. So like when we want to insert something, all we need to do is to reference the parent ID, or we keep it null if it's the parent, or like if it's the first level. So for example, if I have two, let's say menu 0, for example, in the same level, both of them will have the null parent ID. All right. So I hope this was clear, and I hope I answered your question. So let's go back to the chat and let's continue. All right. So shouldn't we use get wishlist instead of wishlist field directly? I will come back to that one. Like I will fix it later on. So how to use the auto completion in IDE. So for me, I did not activate anything. All I did is downloading the latest version of IntelliJ, and it's like a built-in feature. All right. Can we use a set instead of list in the relationship between game and wish list? Like this, we will have the primary key of the table is the compensation of the two foreign keys. Honestly, I did not understand the question in here. Maybe if you can reformulate it, but you need to know the difference between a list and a set. So a set does not accept duplicates, but for the list it accepts the duplicates. So when you have a list of games, you might have the same game many times in the set, like in many wish lists, or like in a wish list. All right, so you need to be careful about that. So like choosing the correct and the best structure, or like data structure, is really important in here, because you need to understand the difference between a set and a subset. But in case, for example, you need to have like unique elements, it's okay to use a set. So what is the difference between join table and join colon again? When to use them exactly? Okay, good question. So a join table is used when you have a many-to-many relationship. All right. So when you have a many-to-many relationship with two entities, you can use the join table to add more customization on the entity that will be created for us. So like in our case, it was the game wishlist. All right. So we want to give it a name, like a specific name, or like a custom name, and we want to specify like we need to specify the relationships, like the game ID and the wishlist ID. When you have like the join columns is when you have a many-to-one and one-to-many relationship, and you want also to have, or like to add extra or like to have a customization over the colon, or like the foreign key colon name. All right, so like we did for game IDs, wishlist ID, and so on and so forth. So this is the difference between them. Join column is when you have many-to-one and one-to-many relationship, and the join table is when you have many-to-many relationships. All right, so yeah. And the next question, is it better to add JSON ignore to avoid entities serialization errors? Okay, I think I understand what you mean, but for that one, we will solve it, or like I will show you the problem, of course, like when we come to that part. I will show you the problem, and then I will explain to you what is the best practice to do that. Okay, JSON ignore or JSON ignore might solve the issue, but it's not the best way to do it. So there are many other ways to do that. All right, any other questions? Do you have further questions? Please go ahead. Question, feedback, something you want to understand, an example you want to see, and also let me push the change. So this one I will just okay, so like for the menu we just added, I will just keep it for you as a reference. So I will just push it. So menu sub menu, submenu. All right. So do we have another question? Yep, we have. Okay. So could error be related to lazy loading in game entity? Okay, if I understand the question. So a lazy loading might be an issue, of course. Okay, so when it can be an issue. So for example, you load the list of games and you want to do the count of wish lists, or the other way around. You load a wish list and you want to load or like get the games inside that wish list. So this is like because of the transaction. I will explain it in details when it comes to that, or maybe let's explain it now. So this also fine, and I can re-explain it again. All right. So here, when we talk about transactions, so this is our timeline. And here, let's say that at this spot, I want to do get wishlist, for example, right? So get wishlist. And I know that within the wish list, I have a list of games. So I have a list of games, all right? So let's assume that this is the time required to get wish list. So this is the time required to get wish list, okay? And then I want to get the list of games. So here, like this one right here, or like this part right here from this to this is my GPA transaction. So this is my transaction. So when I do get wish list, my transaction begins in here and ends in here. And at this spot, so at this spot, or like starting from here, or like maybe I will do it in here. This is the time needed to get the games. Like maybe this is the time needed to get the list of the games. Because within one transaction, imagine like you want to do something and you grab the first thing, and then you want to grab a sub thing or like a sub object of that thing. But the transaction has already ended. All right, so the transaction has already ended. So this means that at this moment the transaction was over. So the transaction here, so the transaction is over. All right, so if I want to get the list of the games, I need to restart a new transaction, but the transaction was already closed from the first one when I asked to get my wish list. So here we have two options, whether to fetch type eager, like to switch the fetch type to eager. So this means that when we load this element, we also load everything which is related, or like which is which has a relationship with it. All right, not all of them, but for example, when we talk about a wish list and a game, and the list of games. Or we need, okay, so I know it's not the time, or like we need to make this one a transactional. So like the whole method needs to be transactional. Transactional means what? Means that we will create a transaction starting from here and ends in here. So like, all right, so ends in here. All right, so all the operation or all the method will run within the same transaction. So like we will open a transaction when the method starts. So here, let's say this is the method start, and the transaction will end, or like will be stopped at the end method, or like the method end. All right, at the end of the method. And the method, I'm talking about any method that you wanted to be a transactional method. All right, so this is what is transactional. Or we can have here, or like we can make it an eager loading, or like an eager loaded. All right, eagerly loaded. So we will see the difference between those two, and we will see also like when to use transactional, what are the best practices, and all this stuff. So we will explain everything in details. All right, let's go back to the questions. Okay, so here, how to add a JSON field in a table. I know it's not the scope. Yeah, it's totally fine. I can answer all your questions. So a JSON field, you mean that a JSON format you want to insert it in a table. So okay, so for this case, I would say you really need to think about this, because we know JSON is not structured, and it really depends on the size of the JSON that you want to store. So like if it's a really long size, like if it's like long data, so you really need to think, you maybe need to rethink about the design of your application. So if you have so many unstructured data, maybe it's better to go for NoSQL database instead of a relational database. So I hope I correctly understood your question. And for this case, maybe you need to rethink about the design of your application. So instead of using a relational database, maybe it's better to use a NoSQL or like a non-relational database, so you can store a JSON format or like any document format within your database or like within your tables. So I will try to answer your question. So for example, let's say if you have, let's say that you have some JSON data or like a JSON format and you want to store it. So all you need to do is to store it as a text, as a string or a varchar in the database or in the table. And then when you get the data, you need to, for example, you can use the object mapper to transform that JSON representation to your Java class, and like this you can use it and work with it as a Java entity or a Java, well, not an entity, I do not mean an Hibernate entity, but a Java class, generally speaking. All right, do you have any other questions? Do you have other questions about today's sessions and what we saw so far? Or if you have any other questions, it's totally fine also. Just go ahead, ask your questions. Do you have questions? Do you have feedback? How beneficial was today's session? Did you learn something new? Did you get something that you do not, or like you didn't know before? Just give me feedback. All right, so I think Junior is trying to explain about the JSON format. So for example, a field address, street, and so on and so forth, it has many fields, so want it as JSON, that's my thinking. So if you have, or like if you already know the structure of the address, for example, or like of this field address, so it would be better to go with creating an entity and all the relationships. So for example, like for an address, you can create, I don't know, like maybe a zip code which composed of the field ABC and so on and so forth. It's better than trying to store only the JSON format, and then you need to manage this JSON format. You need to deserialize it, work with it, serialize it again, and because like the issue is storing JSON into a relational database is when you want to update a field within that, only a single field. So you need to pass the full object. All right, so you need to pass the full object and only to update one information. So this is the first thing. The second one is, imagine in the future, let's say that you have an address, and in the future you have a requirement that all the street names, for example, you want it to be all uppercase. So when you work with like directly within a single field in the database, you can just update table name, set street, for example, equals uppercase of the field itself. So this is gonna work smoothly and perfectly. But when it comes to JSON, you really so you really need to get the data, update everything, and reset the data. So like this is not gonna be so simple. So it's better, as I mentioned, if you know already the full structure of the field address or any other field, it's better to have like dedicated tables for that. All right. So I hope I answered your question. All right, so can you explain methods add wishlist and remove wishlist? Yes, I can explain it. I can re-explain it again. So going back to here. So I will try to bring this one because I really don't know why. I think it might be a Lombok issue. So this is the wish list. I have my getters, my setters, I have everything. Get games. So I have games in here. So this is really weird. Maybe let me try to build the project. Nope. All right, so wish lists are this wish list, and my wish list dot get games, which is in here, dot add and dot remove. All right, maybe I just need to restart my IDE, but I will explain the method first. So so this we will see it in practice. All right, we will see this part in practice, but I just wanted to show it and like to give you a hint beforehand. All right, so here let's draw something new. So here we have our wish list table and we have our game table. All right, so this wish list and game, they both have a many-to-many relationship, which will result in an association table, which is, or like let's call it game wish list, or like wish list games or something like that. So now let's talk about SQL. All right, let's talk about SQL. So here we have this table within our database. So now if I want to insert a new line, so here let's say that I have wish list 1 and I have a list of games 1, 2, 3, and 4. So now when I want to insert something into this table, all right, so I need to insert the ID of the wish list and the ID of the game. So let's say game and wish list, game and wish list, game and wish list. All right, so this is how we insert it. But in our code, we have a many-to-many relationship. We don't have an entity for that. All right, so we don't have an entity dedicated for game wish list. All right, so I cannot, for example, do new game wish list and then set game and then set wish list and I just move on and persist that entity. So now when I want to remove or to add a wish list to a game, or vice versa, so I need to get the current wish list, which is in the game entity, and add my wish list. All right, and then from this given wish list, I need also to link the game, because here we have many-to-many. So like the wish list, so this wish list should have a relationship or like a list of games. So like I need to have a relationship with this. So here I have a list of games. So and inside this list of games, I need to add the IDs that belong to this game wish list. All right, to this wish list, sorry. And so I want to add 1, 2, and 3, for example. And then since I have a many-to-many relationship, so also the game, since the game, it has a list of wish list, needs also to know about this wish list. All right, so here for this game ID 1, it needs to know about this. Game ID 2, it needs to know that it has this one of the lists, also this one. So just to make my code later on, just to make my code easier, all I did here, just creating a method add a wish list or remove a wish list. And adding a wish list, so for now I'll just bring it so the code you can see it correctly. So adding the wish list, I just get the wish lists that belong to the game and add the wish list that I want to add. All right, so here, let's say for example, I have a wish list 2 and the game number 5, and I want here to insert 5 for the game and 2 for the wish list. All right, so now I need for this wish list, I want to add the wish list, and for the game of this wish list, so like these are the games of this wish list, I need also to add the current game. So this, it refers to the game. So maybe this was a bit confusing. So this, it refers to the game. All right. So wishlist dot get games, and for the games I need to add the current game. All right. And I explained it for you. Now let's go back and try to answer some other questions. I hope it was clear for you. All right, so I definitely have to rewatch this video once again to better understand how to use JPA annotations, but the conception is clear. It's great. We can create database without any SQL queries. Yeah, absolutely. And also, if you have other questions while rewatching the video, just drop a comment and I will try to answer as many comments as possible. So maybe game list is null. So no, because it's just a compilation issue. So the null problem might appear when we run the application. All right, but this is a compilation, and maybe Lombok did not work correctly. I will try to fix this and restart the maybe restart my IntelliJ and see what is the problem, if the fix or like if it's something related to the code, and I will explain it first thing during the next time. All right, do you have any other questions? Do you have any other type of questions? Just go ahead, ask, and I will be happy to answer all your questions. Otherwise, I hope you enjoyed today's session, and I will see you in the next one. If you don't have any further questions, I would like to thank you for being here, and I see you in the next one. I will just wait a few seconds. Maybe someone has a question, so I will try to answer it also meanwhile. Otherwise, see you next time. All right, so we have a question. That's good. Okay, is it practice to have database and to map it in code, or to do it this way? Okay, so if I correctly understood, so like you mean creating making the code creates the database, or vice versa? Okay, so the best practice is the vice versa, is having the database and then creating the entities. But for our case, or like when you start a project from scratch, all right, so when you start the project from scratch, you frequently you will add some changes to the database. Frequently you will add some changes to the database. You want to add fields, remove fields, rename fields, and so forth. So for that case, what you like, it's better to start with the code. So since every time you can just restart the application and have the changes directly into the database. But imagine that because most of the time, no, not most of the times, but sometimes you will have an existing database and you need to implement an application for it. All right. So for that case, you will start from an existing database, and then you need to create the entities and the Java classes that will reflect this database, right? Like including the relationships, foreign keys, and so on and so forth. So this is something important, and I really like this question. So like it's both ways. All right, so it's both ways. So when you are starting from scratch, especially for learning projects, all right, it's fine to start from the code and generate the database. But when one day you decide, okay, the idea is good and you want to push it to production, or like to have it on production, and this is something that we will see also in this bootcamp. So in that case, you should not let the code manage the database. And like one major reason for that is, imagine that you do you push some code, and this code is not meant to be released now. And this code, for example, you add you remove some relationships, you add some fields, some entities, and so on and so forth. And this might break the front end, for example. All right, this might break the front end. So in this case, you will cause an issue and you will break your own application just because you allowed the code or Hibernate to manage the database. For that, or this is the reason why we always use database migration tools to manage the database, like Flyway, Liquibase, and so on and so forth. So for example, you need to add a new column into a table. You add you do the changes in the code, and also you need to write an SQL query in order to add or to initialize to add the new column to the table. All right, I will explain it when it comes to the Flyway phase. All right, but the question is very good. All right, so why not use categories for the menu? Okay, so you mean having categories and subcategories. So it's I would say it's a good idea. Why not? We might change it. We might change it later on, like having categories and subcategories, and when we add the game, we assign it to a subcategory. So this might be, or this will be fine. But honestly, I did not think about it in the beginning, but we can adopt this one. All right, thank you. Sorry for the late question. It was a great session. No, it's perfectly fine. You have all the time to ask your questions, and I really liked your question, by the way. Thank you so much for the question. All right, so I think the issue with Lombok is, I guess, if you delete the getter and generate getters, it should work. All right, maybe let me try it. So here I will re-add getter and I will re-add the setter and see if this works. No, it did not. But anyways, so this is not a big deal. This is something that can be fixed. Maybe just restarting the application, the IDE, or just restarting my laptop. I hope so. If it's not, I will let you know. All right, guys. So I think if you don't have any further questions, thank you so much for being here today. It was a great session with you as always. I'm really enjoying your questions. Sometimes you have really great questions. So thank you so much for that. Thank you so much for being here today, and see you next week.